Our next session, I'm out of practice, is with Luca, who is a great chef and a great architect, both for, well, we can argue on the second one, yeah. I don't know what great means, right? So, anyway, without further ado, Luca.
Thanks.
I can't clap in.
Yeah, no worries.
At the same time.
It's fine. Thanks. So, I want to share a secret with you. So, I'm madly in love with software architecture, and I discovered that in the last few years because I always have a lot of empathy towards software architecture. But this time, I understood why. Because mastering software architecture for me means that I can use wherever technology I want or wherever framework I want and use for replicating a specific architecture. Therefore, if I understand the architecture or the design pattern, it doesn't matter if I'm using React or Java or JavaScript, whatever it is. I can replicate exactly that architecture with some twist. And that's why I love that. So if you follow me on socials, you probably know me because I'm tweeting a lot about architecture. I have a newsletter. I wrote a few books on architectures. I really love it. And it's like contagious, I would say. Today, I want to share with you a journey that I did in the last 6 years around micro-frontends. So basically how to embrace the capabilities of microservices and apply that to the front end with a specific framework. In this case, even better, a plugin of Webpack that is Module Federation. So my name is Luca Mezzalira. I'm a principal solution architect at AWS, an international speaker, and O'Reilly author. Okay, so let's start with the definition of micro-frontends. And often, there are people that are asking me, but what's the difference between micro-frontends and components and stuff like that? So I try to nail it in this definition. Micro-frontends are a technical representation of a business subdomain. They allow independent implementations with same or different technology. And they minimize the code share and is owned by a single team. Now, there are a lot of things that distinguish a micro-frontend compared to anything else. So let's try to deep dive. First of all, technical representation of business subdomain. If you're familiar with domain-driven design, usually we use domain-driven design for taking a complex system and then break it apart, and then we use that also in later days for dividing the organization in a way that the architecture became an enabler for developers to create independent artifacts. And we are doing the same also on the front end, potentially. The other thing is independent implementation. Usually one thing that you recognize very well in micro-frontend is because you can ship it independently without coordinating with other teams. Obviously, it's not always the case. Sometimes you need to coordinate with other teams. Sometimes you really need to spend time and, let's say, maybe you have like a change of design system, wherever it is, and you need to coordinate for making sure that the user experience is compelling and cohesive. And therefore, you need to do that. But the vast majority of the time, you can add new functionalities in your micro-frontends, ship it, and you don't have to coordinate with anyone else. More often than not, you hear that micro-frontends is just an excuse to use a gazillion of frameworks in the same system. The reality is, whatever is true for single-page application or server-side rendering is true for micro-frontends. We need to think about our users, about, let's say, infrastructure that are not as great as in US or UK. And therefore, we need to think about that. But there is, let's say, one use case that I think is very compelling for micro-frontends for using multiple technologies. That is when you want to migrate a legacy application towards this world or the micro-frontends. And the beauty of this is that you can potentially use a different framework or the same framework with a different version and slowly but steady killing the legacy application using patterns like the strangler pattern that is well known in the microservices world. Then another important thing on distributed system is that you try to minimize the code share. Because more external dependencies you have inside your system and inside your team, and more you are slowing down. And then you could end up in the trap of a modular monolith that is the worst of both worlds. So therefore, you need to be careful on when to share libraries and when to share code across teams and when not. And finally, the ownership part. I truly believe on you build it, you own it, you run it model where you try to have the ownership of the team. So the team should be empowered to make changes on their CI/CD. They should be empowered to create their observability tools and dashboards in order to understand what's happening. And that's why I think it's very important that micro-frontends, like microservices, should be owned by a single team. That means that other teams can contribute, but the final say to merge the code with a micro-frontend should be done by the team that is owning that micro-frontend. And because of that, I thought, okay, so it's early days for micro-frontends. We need to create slightly more documentation, slightly more things. And I came up with this mental model in 2019 called the Decisions Framework that is composed by 4 key pillars. And those 4 key pillars will allow you to define upfront your system, and then you can follow them for any other decision in your micro-frontends application. So first you need to define what a micro-frontend is. So you can have multiple micro-frontends in the same view, or one micro-frontend that is represented by a view. You can compose micro-frontends. How you are going to do that? On the server side, on the edge side, on client side. And then you need also to decide how to route micro-frontends. So if the user is selecting a link, how you go to the next view. That's another thing that you need to identify. And finally, the communication. So if you have a communication that multiple micro-frontends in the same view, you need to communicate with each other in somehow. It's impossible to think that you are going to have encapsulated micro-frontend that will never discuss. Otherwise, you are basically rendering a static website that is far to be a great experience. So we will see all of this in the example that I'm going to share today. Okay, so first of all, if you don't know Webpack, because that's what we're going to discuss today, Webpack is a JavaScript module bundler, and I think is nowadays very well known. And one thing that added in the latest version that is available also for version 4, but with limited capabilities, is Module Federation. It's a plugin that you can have there. And the beauty of Module Federation is that you can dynamically load a different bundle inside your application. So what it means is it could be a library, it could be a component, it could be a micro-frontend in this case. And we are going to leverage this because we can create independent systems, as the definition, that can be loaded inside, let's say, a container that will allow us to create micro-frontends. Because I like visual things, I created this diagram. So imagine, for instance, that you have, like here, multiple micro-frontends, okay? And multiple teams are developing those micro-frontends. With Module Federation is taking care of creating the multiple chunks of JavaScript that then will be loaded inside the browser. And then what it does, I don't remember if I have this animation. Yes. What it does allows you to, when you have like 2 different views, like catalog and my account, when you have like, as you can see here, similar chunks, so chunk 14 is in both, it will be loaded just once. So you don't have to take care about sharing dependencies and all the other things. Webpack will take care for you about this stuff. That is great, because usually that is an optimization that requires a lot of thought, especially in a large organization, when you want to handle that. It's not the only solution that does that. There are other possibilities, but today we are going to explore this one. Before we jump on the code, let's see a bit of configuration that I think is very important. So the configuration of Module Federation is very simple. So you create a Module Federation plugin. So if you're familiar with Webpack plugins, inside the plugins array, you can create one new plugin. And what you have is, first, we have 2 concepts. We have the remote and the host. The remote is something that is loaded inside the host, so it's a bundle, JavaScript bundle that is loading inside the host, and the host is the container of these, in this case, micro-frontends. So in this case, what we have is a remote example. So what will be loaded? And what you have is, first you need to define a file name for the remote. That name basically specify the list of chunks that will be produced, JavaScript chunks that will be produced by Webpack. And inside here, if you inspect that, you will have a list of, okay, so this micro-frontend or this library is composed by 3 chunks, and those are the numbers. And that is basically the entry point of your micro-frontend in this case. That is describing what to load. Then you can decide to expose one entry point, like in the case of micro-frontend, or multiple one. Imagine, for instance, you want to lazy load a design system. Potentially what you could have is listing here all the different components, and then you can cherry pick what you want to load. And then based on that, module federation will react. And, oh, sorry, forgot this. And finally, share dependencies. What you can say, and is mandatory in order to share the dependencies across the whole project, is defining what libraries should be shared across the entire system. And in this case, in every remote, I have to say, okay, I want to share React, and I want this loaded just once. That's what singleton true. Yeah, the singleton true is going to show you, and it's just saying to in this case module federation that has to load that version just once. You can go more wild in the way how you configure the dependency. You can specify a specific version of a dependency, and maybe that is not the same that is used on the rest of the project. But Webpack, basically what it does behind the scene is creating a container, so the scope of that specific library will be contained inside that container in JavaScript, and is not going to clash with the same library but a different version. That is, let's say, another perk that you have using this approach. Then, when we talk about the host has a slightly different implementation. So the first thing that you have is you list all the remotes. So how many micro-frontends I want to load inside my container in this case. And in this case, I just have this, but potentially I can have 10 of them. It's no problem. It's up to you how you want to handle that. And then, again, we need to repeat what is going to be shared. Based on that, Webpack will basically extract all the code that is needed and bundle all in multiple chunks. The beauty of this is, because you're using Webpack, module federation can be tweaked using other plugins of Webpack. So potentially, if you don't like to have a very chattiness communication between the server and or the origin and the client, you can reduce the amount of chunks that module federation is producing, and then therefore you can have, let's say, a different result. So it's just a modular system because at the end is a plugin. So today we're going to see this. And I wanted to take this, let's say, create this diagram because I think it's easier to squeeze in our head what we are going to see. So as you can see here, we have what is called the application shell. The usually micro-frontends, in the micro-frontends terminology or vocabulary, is usually the container of all the micro-frontends. And that basically persists for the entire user session. So when you go to a website, first thing that is loaded, in the case of this architecture, is going to load an application shell that remains there for the entire user session. And then the application shell in this case contains the navigation and the header, and we will load different micro-frontends. We have the sign-in micro-frontend, we have a catalog and catalog details, and then we have a very special one, so multiple micro-frontends inside the application shell. In every single of them, you will see that there are some challenges that usually are the most common challenges that I found in the last 6 years when I was talking about micro-frontends and consulting different customers. So let's start with this. This is basically a demo that I created. As you can see, we have the sign-in micro-frontend is loaded. Now I'm just adding my username and password. And then I click sign in. I go to the catalog. This is another micro-frontend, and I can go to an internal route of the catalog, that is the detail page. And then this part here, the header is living in the application shell. Also, the navigation is living in the application shell. So now I go to my account. Those are two micro-frontends, as you can see. But the experience for the user is seamless how you would have with other implementations. So here we have, for instance, a communication between two micro-frontends. I click change payment method to PayPal, and I change the date there. So as you can see, there are a few things that, let's say, are quite common, but with micro-frontends, in order to maintain the distributed nature, we need to slightly change the way how we work. So here, for instance, I'm just showing that I have my token, because I sign in, that is stored in my local session storage, and then I clear it, and I go back to sign in. I don't sign in, I go to my account, and I'm outside my authenticated area. So also we are going to cover the authentication part. Okay, so let's start with this project. At the end of the presentation, I will share with you the link so you can deep dive on the code. So the project in this case is a monorepo, but mainly because I was the only one that was writing there. Also polyrepo are completely fine working with micro-frontends. So every repository that you will see in the demo is composed by this. So you will have like a source folder with the entry point of micro-frontend. The micro-frontends on purpose are really simple. Then we have the Webpack configuration, that is the other important part. So all of them are like that. Now, the application shell configuration for the demo is this one. So as we have seen, there are multiple remotes, and in this case we have 3 micro-frontends. Okay, so we have the my account that is containing 2 other micro-frontends, the catalog, and the sign in. Oh, by the way, obviously the configuration has to be tweaked by environment, right? So you can potentially with Webpack create, let's say, a logic that will load a different URL. Now I'm working localhost because I'm developing that, but potentially you can use something else. Even further, a few weeks ago there was a new implementation of module federation that allows you to, via JavaScript, lazy load your remote. And in that case, basically you don't even have to specify this. You will do that through your orchestration layer that usually in this case will live inside the application shell. And then I have all the shared dependencies that then will be exported and loaded once by my application. So after that, when we decided how to structure our micro-frontends, we need to think about the composition and the routing part. And the composition is fairly simple. So I extracted 3 bits of code let's say, because I didn't want to share all the styles and everything that I have done with the design system. So first of all, I'm using, as you can see, a React router. So nothing new there. I'm not reinventing the wheel, creating a custom router or whatever. I'm just using what I'm used to do if I'm a React developer. Obviously, with Angular, you can use whatever you're using in Angular and review the same. It's completely framework agnostic. And then what I can do here is just say, okay, so every time that you hit this URL, so /my account, you call the function render MFE. And render MFE accepts, let's say, an object that is, in this case, 1 component. The component, in this case, in React, is using 2 key constructs. First of all, the React lazy, that is used for lazy loading a specific component. In this case, for us, it's a micro-frontend. But as you can see here, because module federation behind the scene is handling the retrieval of the specific micro-frontend, I can easily just use it with a slightly different syntax like you would import any other component. Okay? And in order to let's say, display something with a lazy component inside the tree, the DOM tree, what React offers us is React Suspense. That currently is experimental, but is going to be embedded in React 18. And what it does, React Suspense, is just saying to the virtual DOM, hang on, because I know that something is coming, but it's not there yet. So in the meanwhile, we can use a fallback that is as simple as string or a component. The other thing is design system. One of the main complaints around micro-frontends is we are not able to create something cohesive and that is using our design system. In reality, you can do that. So this one is Material UI, it's a fairly famous one. And the trick over there, for instance, in Material UI is having some prefix on every single class style that you have in CSS in order to avoid clashes that could happen at runtime. So in that case, you can add the name of your micro-frontend that then will have, I don't know, dash button, whatever. And another technique that I invite you to look at on CSS is using the beam technique that you can find on Smashing Magazine, and there are a lot of information around how to name basically the classes for creating unique identifier. So then, yes, design systems are totally possible on micro-frontends. Then the other thing is our remote. So how we structure our remote. Once again, we have the name of the remote, the file name, and then we have what we expose and everything that is shared. All the remote are similar. Obviously, I changed some parameter, but in reality, that's what you got. And then we start to go on the, let's say, painful feature usually. So the first one is how we are going to share a token, for instance, a session token. Now, considering that you have one micro-frontend or multiple micro-frontends in the same view, imagine that you are in an authenticated area and every micro-frontend that is, again, an independent artifact has to fetch some APIs using a bearer token, like a JWT token. So in order to do that, what you do is you share in a common place where every micro-frontend can fetch it. And in this case, could be either the session storage, local storage, cookie, wherever it's more comfortable for you or wherever meets your security requirements. And in this case, what you could do is saying, by convention, all micro-frontends, if you want the JWT token, you can use, let's say, you can find in this place. And when you have done that, basically, for me, the user is signing in, and I'm using basically the history API of React Router for pushing the user to the next micro-frontend. This basically push will be picked by the React Router that is living inside the application shell, and will load the new micro-frontend. In the catalog side, we have another challenge of micro-frontends. So I want to have the possibility to have a local routing. So if an application shell is responsible to handle the global routing, or what when I move from one view to another one, or from one domain to another one, in terms of domain-driven design, not domain like URL domain, in this case, I can have like a local routing that is handled by my micro-frontend. So I can evolve this and just saying everything that is at the second level of my URL will have the possibility to be handled by a single team. So they don't need to have external dependencies from other teams or communicating with other teams. They know that as /catalog, they have loaded their micro-frontend, and they can append wherever they want in the URL because they are autonomous. So in this case, in order to do this, as you can see here, we have the React route entry point that is wherever is with this, I think it was shop, the entry point here on the path. And then I have shop/product/product ID. And this is handled inside the micro-frontend. Don't have to communicate with anyone else. Probably having a chat with the SEO manager if you have one. But apart from that, you can handle inside your micro-frontend. So the interesting part here is that I can pass other kind of information, more ephemeral, in a different way. You don't have to pass always through the local storage, session storage. But for instance, if I select an element like I did in the video that I recorded inside the shop, every element has an ID. So I can pass that ID in query string and rely on the fact that the next view, that could be either the same micro-frontend or a different one, will be take that ID and use that for fetching some data related to that specific element that was selected by the user. So once again, the mental model here is ephemeral data can go through query strings, but important data should be like tokens, should be stored inside session storage or cookies. The other interesting approach is when you have multiple micro-frontends inside another container. So my account, for instance, if you remember the diagram that I showed before, was containing 2 micro-frontends. And basically my account, what it is just a container. It's nothing else. And is acting exactly in the same way like the application shell. So the simplicity here is that, again, I'm describing which micro-frontends I'm going to use is exactly the same configuration we had in application shell, because Webpack allows you to have bidirectional, if you want, communication or loading between elements. So potentially a host can load from a remote and the remote can load from the host. In this case, I highly discourage that practice. If you have a unidirectional loading where you start from so the host will never expose anything for any remote, that, in my opinion, will simplify dramatically the debugging of your applications. But technically speaking, is doable because is allowed in module federation. So here I have 2 micro-frontends. And the challenge we said before is around communication. So communication, usually the first thing that many developers I heard are thinking is, okay, I create a global state, and then I share basically all my properties there. The problem with that is basically you are creating a design coupling. So if you have two independent teams that are working with a shared state, global state, you are basically coupling those teams. And every time that there is a change, they need to work together in order to make sure that their micro-frontend is not blowing up. And if there are two, maybe it's doable, but if you have 10, probably it's less. So usually the best way is learning from what microservices were doing and using something like an event emitter or custom events. Anything that is resemble to a pub sub pattern is definitely what you should look at. So in this case, I took like this nano events library, and I'm using that for the communication between the two micro-frontends. In this way, I can create the event emitter in this case, and then I inject inside this authenticated view. That what it does is nothing more than taking the two micro-frontends and then injecting the emitter as a property. So you have an event emitter basically now that is available inside your micro-frontends, and micro-frontends can dispatch event through the event emitter. And in this example, we are doing exactly this. So when I click the button of on change payment method, I call this on payment change, and I emitting an event that is payment change and also a payload. In this case, I use strings, but you can be more prescriptive and having object, or you have, if you're using TypeScript, even better, because that became even easier to follow. And when you are doing this, basically what's happening on the other side is someone else, another micro-frontend, is listening to this event. So I have like emitter.on. When payment change is triggered, something happens. In this case, I'm changing the value of the my string. But the beauty of this approach, imagine now that I add a new micro-frontend. It's a new team, and they need to do something when payment is changed. So now I don't have to coordinate with anyone. As long as I know that I have a payment change method that is triggered by someone, the only thing that I have to do in my code base is adding one line of code that is saying, listen to this event, and when that event is triggered, do something. And the beauty of this is that you are creating a real decoupling between teams because you are maintaining them independent, and they can evolve their project and their micro-frontend independently. And the only thing that they need to do is documenting properly the input and output of their micro-frontend. When that happens, you can scale the organization. I cannot say as much as you want, but close to. So basically, in summary, what we have seen is an approach of micro-frontends that basically is trying to simplify the way how you are building your project. But moreover, as you have seen, the code is nothing that is custom for micro-frontends. It's something that probably you have written several times if you're working with React. Moreover, we have seen how to apply the decisions framework using the possibility to have sharing token in the case of sign-in, local routing in the case of the catalog, and multiple micro-frontends inside the same view and how they communicate together. So all of these are the common challenges that usually you find in micro-frontends and are solvable sometimes easily if you follow, let's say, a few of these approaches. If you, that's it for me. And thank you very much for listening. If you are interested on more about the decision framework, if you search online about my name and the decision framework, you can find several articles that are describing all the different options that you have based on the composition that you decide. If you want to do client-side rendering, server-side rendering, or edge-side rendering. That's it for me, and thank you very much.
We can take a few questions if you want.
Yeah.
If you want, you don't have to.
Yeah. What's that? Thank you.
Only Luca gets it.
Yeah. Sorry about that. Any question? Yeah, there are a couple. So, Eduardo? Okay, so the question is, what happens if I have multiple micro-frontends in the same view, and someone starts to emit the event before all the micro-frontends are loaded? Yeah, so the question is quite common. Thanks for the question. I didn't mention that. But usually you create a buffer. So the container basically does the buffer for replaying the events when because the container knows when everything is loaded. And therefore what you do is, it's a bit more complex, but what you do is storing in an array all the events and the payload, and basically you store objects. And then when all micro-frontends are ready, you just start to emit stuff. The other way around that you can do that, that potentially could be another option, instead of maintaining a buffer, is sending every micro-frontend by convention has let's say on start or everything is loaded event that has to listen, and in that case they can start to emit event. So you have two ways, and one, let's say, is maintaining the independence of the micro-frontends because you are creating a sort of more logic for handling and replaying the events. Or you can say by convention, I stop that and you start to emit event only when I tell you to do so. So if you have multiple micro-frontends in the same view, usually, as I showed here in my account, is a container of multiple micro-frontends. Then if you don't have another container you load directly in the application shell, because it's not domain specific, it's something common for the entire application, you can build inside the application shell. Different version of the... you mean for the dependencies or for the micro-frontend? Dependencies. Okay. Yeah, so the question is, how can you handle a multi-environment strategy that are running multiple versions of micro-frontends? Through artifact promotions. So in your CI/CD, basically you need to have a way to say, okay, I always load the latest on development. When you are happy with that, if you extract all the, let's say, environment variables that are related to that specific thing and can be injected inside the micro-frontend, then you can promote the micro-frontend to the next stage, and it will receive a new bunch of environment variables that will allow it to use exactly the same code was running in development that was working, but in a different context. And that you go through all the environments promoting the things. But you need to have a solid CI/CD for doing that.
Thank you.